अब students, एक नया concept which is related to digital signals but includes our analog composite signals as well is we can decompose or we can express a digital signal as a equivalent set of composite signals or a composite signal. Students, the analysis technique that we use to do that is Fourier analysis. And we will talk about Fourier transforms and Fourier analysis in the later discussions. But for now, what you need to know is that a digital signal can be expressed as a composite signal. Students, when we express the digital signal as a composite signal, it is a combination of multiple horizontal and vertical lines that combine to form a pattern. It will obviously have infinite bandwidth, because we are talking about a set of frequencies which will start from 0, and I'll explain it to you in a little bit, and they will go all the way to infinite. So students, slide pe chalte hain, and I'll try to explain this concept of how we express the digital signal into a composite signal, especially when the digital signal is periodic, which is rarely the case, and when the digital signal is non-periodic, which is normally the case. Students, digital signal as a composite analog signal, what you can see is that we have used Fourier analysis, and all that you need to know at the moment about this technique is just the name. So don't worry about the fact that you don't know what Fourier analysis is. So Fourier analysis is what we use. Fourier was the name of a communication of a scientist, by the way. So Fourier analysis is used to decompose a digital signal. In the first case, what you're looking at is a digital signal which is periodic, very rare in data communication, but we'll still talk about it. Students, in this case, what you have on the left-hand side is a time domain plot of this periodic digital signal. Students, what we have done is we have converted this into its equivalent frequency domain plot in here. Students, it's very clear that if the digital signal that we are looking at, if it's periodic, the decomposed signal has a frequency domain representation given by the right hand side with an infinite bandwidth. The spikes that you're looking at, they start from frequency of f and they are infinite. They go from f to all the way to infinite. Now this essentially means, students, that we have got infinite bandwidth and discrete frequencies. Students, we'll go to our second figure, which is showing an non-periodic digital signal. On the left-hand side, once again, you have a time domain plot. On the right-hand side, you have a frequency domain plot. Students, once again, the decomposed signal, it still has infinite bandwidth, but the frequencies are continuous, discrete. All the frequencies for a periodic digital signal are discrete. In the case of a non-periodic signal, we have frequencies which are continuous. Students, gaur kijiyega, vertical lines in the time domain, and we'll discuss them further when we go to the next topics. They represent a frequency of infinity. This vertical line represents that there is an instantaneous change. और हमने ये पढ़ा था कि जब भी instantaneous change होती है in the time domain plot, that equates to a frequency of infinity. The horizontal lines in the time domain equate to a frequency of 0. Remember, frequency is 1 over period. Now, students, a very important point to note is that both bandwidths are infinite, but the periodic signal has discrete frequencies once again, and the non-periodic signal has continuous frequencies.